You're listening to Strange by Nature, your guide to the strange, weird, unbelievable, and improbable wonders of the natural world.
Hello everyone, thanks for being here today. I am Kirk Mona and I am joined today by Rachel Ginza and Victoria Thompson. We are all professional naturalists who together have scoured the world for weird and wonderful wonders just to please your mammalian brain's desire for novelty. Isn't that nice? Let's do this.
Hey everyone, welcome back to the show. Really excited to have you here. This week it's just Rachel and me. We got some fun stories for you.
Okay, you say that like we're not a riot between the two of us.
It's gonna be a whole thing and a whole deal. It's gonna be amazing. But we all Victoria is off this week, so we don't have a guest this week. So we have some other guests we are lining up to come be on the show. But this week we thought it'd be fun just to have the two of us and give us a little more time to talk about some very fun topics. At least I know mine is very fun. Those of you who don't know, we never share our topics in advance. Part of the impetus behind doing this whole podcast was the idea that we just want to surprise each other. And what are those sort of over-the-top things naturalists talk to each other about and saying, well, have you heard about this? And see if we can come up with stuff that maybe the other person hasn't heard of. And I'm thinking maybe today, Rachel, I may have one for you that you haven't heard about.
Ooh, I'm very intrigued because I know that you know about mine.
Well, you probably remember a few weeks back, we had Alicia on, and they had a great story about purple dye and the great lengths that dyers went to manufacture that dye from essentially snail slime. Do you remember this? It was fantastic.
I do remember that, yeah.
It made me appreciate the color purple even more. And then keeping on that color kick, we had another guest, Marika from All Around Animals podcast, and she talked about our perception of color. And so those went together really well. She talked about how some animals are monochromats. They really just kind of see in essentially black and white. Some are dichromats, seeing like they have two different types of color sensors in their eyes. Some are trichromats, most famously like, humans. But we also touched on tetrachromats as well. So if you didn't hear either of those episodes, definitely go back and check those out. It is fair to say that color has been on my mind lately because of those episodes. And randomly, YouTube recommended a video to me, or maybe it was like listening in on my brain somehow. But perhaps because I've been thinking about color, I instantly clicked on it. It was a science video from Steve Mold, who if you haven't seen him or discovered his channel, you for sure should check him out as he produces excellent and really interesting science videos. So Steve was interested in a question that ties in really nicely with our last two guests. And so I want to explore some of the same ideas he did in a series of videos from about a year ago. So a podcast is not a visual medium, so you're going to have to use your imagination here for a moment. But and I will say that red-green colorblind people may find my topic perplexing today, but actually their unique eye setup is key to understanding a sort of philosophical quandary that we're going to get into later. So first up, I want everyone to picture and think about rainbows. Rainbows are really just a handy stand-in this case for, the full spectrum of colors that we see, right? If we could see a wider range of colors, we would see a wider rainbow, right?
Right.
But we're stuck with good old Roy G. Biv. And I remember my dad teaching me about Roy G. Biv when I was a child. I assume most people listening learn the color spectrum this way, but just in case they have no idea what I'm talking about. Rachel, you know who Roy G. Biv is? Do you know?
I mean, I think I know the story, but not off the top of my head. I mean, it's Roy G. Biv.
Well, this is like, if you didn't learn the color spectrum this way, you're like, what the heck are you talking about? The name Roy G. Biv is not a real person. It's just a trick to remember the order of colors in the rainbow or in the color spectrum, right? R is for red, O is for orange, Y is for yellow, G is for green, B for blue, and I and V are for indigo and violet.
Right.
So why we give two names to what is essentially shades of purple at the end of the rainbow there, we can actually blame Sir Isaac Newton for that. He was a genius, but also a bit of a mystic who was into numerology and spiritualism and stuff. And he basically thought that the number 7 was a magic number. and like one of like the perfect numbers in the universe. So we absolutely had to have 7 main colors, and thus purple got split into 2 important shades, sort of indigo and violet. And some people argue that indigo is more of a blue, but often it's shown as kind of a purple color.
Right.
And it's really weird that we split purple into 2, but we didn't bother splitting blue into blue and cyan.
Right.
Because, well, I guess 8 isn't a magic number. So
I'd rather have like cyan actually,
because
cyan is like a much brighter color. Like it's a blue, sure, but
and actually super important in all kinds of colors and dye processes and whatnot too.
Exactly.
That's what the C in CMYK for like your toner in your printer at home. That C is for cyan. So anywho, I hope you can picture this color spectrum in your head. Marika talked about how the cones in our eyes can detect colored light, and those cones are often called red, green, and blue cones. They're technically a bit more complicated than that, but you do hear that terminology out there. If red light hits a red cone, our brain interprets that and sees red. If blue light hits a blue cone, we see blue. Green sees green. This is not rocket science.
Mm-hmm.
Now we can mix those to make other colors. So if both red and green are stimulated at the same time, we see either orange or yellow. And if you think about Roy G. Biv, the orange and yellow are in between red and green. So if there's a little more red than green, we see orange. If there's a little more green than red, we see yellow. But we don't really have receptors for orange or receptors for yellow. It's just a trick of how the light hits those receptors we have. So hopefully that's pretty straightforward. The same idea is actually used by computers and TV monitors, where each pixel is actually 3 colors, red, green, and blue. And to make any color you want, the monitor just changes the brightness of each color in a pixel, and our eyes and brain combine them together to make the colors we see. And this brings us to an interesting problem, though.
Oh.
Think back to our color spectrum.
Oh,
okay?
Okay.
So sure, if my eye detects 50% blue and 50% green, I will see this blue-green color that we call cyan, because it is the color directly between them on the spectrum.
Right.
But what about purple? Now, this was actually the question that Steve Mould was trying to address in his video. How on earth does a computer monitor create the color purple? There's only 3 colors in each pixel, red, green, and blue.
Right.
That's why it's sometimes called an RGB monitor or screen. But purple is not one of those colors. Now, I mix the color. If you want to make a color, right, you would mix the color to the left and right of it on the color spectrum to produce it. Okay, well, on one side, I have blue, and that makes sense because purple is kind of bluish, right? So I'm going to use blue as the one color inside. But the color on the other side of purple is ultraviolet, which is a color that we can't see.
Right.
Right? So you can't mix ultraviolet and blue to make purple, which is how we make the other colors in our eye, is by combining the colors on each side. But that doesn't work for purple.
Huh.
If you have a remote, yeah, it's weird, right?
Yeah.
If you have incidentally a remote control at home for like changing the TV and whatnot, you might notice there's an LED on the end that you point toward the TV.
Mm-hmm.
It does light up every time you press a button, but you can't see it lighting up because it's using ultraviolet light to communicate with the TV, and our eyes cannot detect ultraviolet. We literally don't have a cone cell that can detect that frequency of light. So, to create purple, we would really need a computer monitor with 4 LEDs for each pixel. Instead of an RGB monitor, it would make sense that we need an RGBU monitor with the U standing for ultraviolet. It wouldn't work, mind you, because we can't see ultraviolet, but in theory, for an animal like a bee or a bird that can see ultraviolet, I'm guessing this would be a perfectly fine way to make the color purple. Just turn on the blue and ultraviolet LEDs, and the eyes of those animals would see purple. So here's the weird question then. If we can't see ultraviolet, and we only have cones that can see red, green, and blue, then how on earth do we see the color purple?
Yeah.
It seems like it shouldn't be possible.
Right. Technically, like, yeah, because all I'm thinking about is like when I do like paint pigments, like you mix red and blue, but that doesn't work the same way for light.
Except It maybe kind of does. So here's this weird thing. Yeah, this gets pretty weird. If you're a human listening to this, and unless you're red-green colorblind, you're probably thinking to yourself, like you are, Rachel, hold on, I'm pretty sure I've seen the color purple.
Right.
Right? So how do we make this happen? Maybe look around your room. Maybe you're seeing something purple right at this moment.
I own many purple things,
yes. See it somehow. Right. So here's the answer. Color is an illusion. It is something we make up in our brains as a way to interpret frequencies of energy. There really is no such thing as the color blue or the color purple or the color red. Those are just frequencies of energy that our brain is interpreting into something that we can perceive as color.
Right.
Okay? So the color purple, though, may be even more of an illusion than all the others. So you were talking about paint pigments, and if there's any artists listening who remember that basic color theory, like you said, if you mix red and purple, or sorry, no, red and blue, you get purple, right? Think about that for a second. You're going to mix blue, which is next to purple on the color spectrum, with red, which is way over on the other far end of the spectrum. It is nowhere near purple. So if we're talking about these frequencies of light, we're going to mix something from way over on this end into the blue, and it's going to make purple. Which
wouldn't
is
that technically, like for light, wouldn't that create green?
Well, when you're mixing different, you are correct that when you're mixing different, like mixing light is different than mixing pigments,
right? Because it would just,
but for
well, my thought
it's
was
confusing.
It's very confusing. But my thought is like your eye would just average it, like, oh well, this segment, this frequency and this frequency in the middle. That average is
no. See, it doesn't. That's not how our brain works. It's not averaging it out.
Okay.
So what's really happening is, the blue cones in your eye do get stimulated by some of the purple light that's coming, that purple frequency. When I said we have red, green, and blue cones, some scientists don't like to use those terms because really those cones are sensitive to a variety of frequencies. That's why the blue ones can pick up purple light at all, because they are somewhat stimulated by light at that frequency. Likewise, that turns out the red cones in the eye are actually sensitive to a really wide spectrum of light too. And when we see the color, violet, let's say, which is scientifically a frequency of light at 380 nanometers, both the blue and a little bit of the red cones are stimulated. And our brain combines the signal from the blue and the red in our brain and goes, oh, purple. And indeed, I hinted at earlier, if you are red-green colorblind, you cannot see the color purple because there's no red signal to mix with the blue signal to make purple. For those of us that can see red, we combine it with the blue signal and we call what we can see purple. But my question is that accurate though? I mean, purple is real. I can see it. It is a real distinct color that appears on the spectrum. I can make purple paint. I can wear a purple shirt. We can take the slime from snails and make purple dye out of it. But it doesn't seem to make any sense from sort of a scientific view of how the rainbow works and the color spectrum works. Red is about as far away from blue as possible. But when I start on blue and move away from red on the spectrum, the resulting color is blue with a lot of red mixed in. Like, that doesn't make any sense. And what we see as purple is just our brain's way of interpreting a certain frequency of energy, right?
Right.
And the color we see is a quirk of our visual system that happens to have really wide filters on our red cones. So how animals perceive color is extremely complicated. If an animal that has cones that are less sensitive to red, but they can also see ultraviolet, there's a good chance they see a color in the same place we see purple, but their personal perception of that color could actually be completely different than what we see.
Isn't that
I don't
wild?
think we really have an answer for that. They may see a color in that spot on the rainbow,
Mm-hmm.
and they may see it and go, if they could talk, say, oh yeah, that's purple. And we could both look at it and go,
That's
yes, that's purple.
purple.
But the actual color they see may be different because they may be combining ultraviolet and blue instead of combining red and blue
Mm-hmm.
to make what they call purple, which
And
sort of breaks my brain.
yeah, like that's something like we can't
Right?
even fathom what that color is. Oh,
Yeah. Now I'm curious. There are some humans who have had like eye surgery where they put in an artificial lens, and it's actually the lens of our eye that blocks some of the ultraviolet light coming in. Or some of our cones and whatnot can actually detect ultraviolet. So I'm curious, does purple look different to those people? And we probably can't answer it specifically like if it would look how it looked to other animals, because you're still mixing a lot of the red in, right? Because the red cones are still sensitive to that. But it's like, that's an intriguing little like, does purple look different to those people? Very,
you know who
very
I would
intriguing.
ask? I would ask someone who was
Who's that?
red-green colorblind, but has an artificial lens over their eye.
Oof, so we gotta hunt down. That's a very specific.
That is a very
person. We have to find
specific
answer that
person.
question.
Yeah.
Yeah, interesting. So look, our perception of colors is crazy complicated. Is what it comes down to. And my goal for this week was just to, make everyone really ponder how truly strange the color purple is, and maybe appreciate what a strange planet we live on.
Oh, thanks, Kirk. Yep. This is like when I broke your brain. This is like when I broke your brain about the color magenta.
Mm-hmm.
My God.
Yeah, I think colors are fascinating.
Oh, they are.
Well, we're going to take a break. We'll give everyone's chance to sort of, get your brain back in order after that one. And we'll see everybody after the break. Rachel, you got something special for us, right?
Oh, yeah.
Awesome. See you soon. Hey, everyone. I wanted to give a quick shout out this week to Ryan Crum. Ryan, I hope you're listening. Ryan is getting a shout out because he's the newest member of the Society of Strange.
Yay!
These are listeners just like you that enjoy the show enough to contribute over at patreon.com/strangebynature. People like Ryan help literally pay the bills. And let me tell you, producing a podcast isn't free. So if you like what you hear each week and want to help us keep on going and making the show, you can be like Ryan and head over to patreon.com/strangebynature and check out our different support levels and some of the things you get with those levels. But thanks so much to all of our patrons. And if you're not one of our patrons yet, hopefully we'll see you there soon. But let's get back to the show.
All right. Welcome back, everyone. I mentioned it at the top of the show, but this week I'm talking about something that I'm pretty sure most of us have heard about. Otherwise,
most of us. You hinted that
I know that
about
you
it,
have heard about
has?
this for sure.
Ooh,
but
okay.
I have a
All
feeling that a lot of our listeners has heard about this thing.
Okay.
Well, I mean, otherwise, to be fair, you and I, Kirk, and Victoria, we occupy a specific niche of people who know way too much about a lot of different topics.
We are Renaissance people, if you will, who we love knowing. Our knowledge is very wide, not always deep in every area, but as a naturalist, we try to know a little bit about everything.
Exactly.
So when we're presented with something novel, we can use all of our little bippity-boop knowledge from around the world to sort of suss out what's going on.
Exactly, which is why I think most people will know about this, but who knows?
We got a lot of weird listeners, so hopefully,
that's true.
Let's find out.
So this week, before I get into what it actually is, I do want to actually...
You're teasing us, Rachel.
I'm teasing so hard. So one of the things that we do as naturalists, I know you don't tend to do this as much, and I have stepped away from this a little bit, but one of the one of the activities that we teach with kids is fishing. I have taught ice fishing and things like that to kids. I've taught actual fishing to kids. And usually it's not so much casting, learning how to cast or anything like that. It's quite literally just getting the experience of putting some bait on a hook, dropping it down, and letting them catch whatever they get.
Rod or something.
Exactly. Yep. Now, at least here in the Midwest, Minnesota, a lot of the fish that these kids catch are bluegills and sunfish and these panfish.
Yeah, little sunfish.
Right?
Yep.
And they're cute little round fish with a really like nice dorsal fin and has a pretty distinct back fin that.
Okay.
But I'm not talking about like lake sunfish today.
Oh, Rachel.
Uh-huh.
I'm excited for your topic. I know what this is.
Yeah, you do. Today I'm talking about...
I'm betting a lot of our listeners don't know about this.
Oh my gosh. I hope they do. So today I'm talking about the mola mola, or the...
the mola mola.
Mola mola. Thankfully, that is Latin. I can speak very easily. Also known as the oceanic sunfish. So it's not like the sunfish that most people like when they go out fishing. It's generally like the fish that you catch is a type of sunfish. This is not that.
I need to find an envelope here. I have an award I need to send you, Rachel, for the, where did I put that envelope? Understatement of the Year award. I'll have to find that. I'll mail it off to you.
Oh, thanks.
Yeah, no, this is not the sunfish small children
can catch with like a little bit of corn.
Oh, no.
No. So the oceanic sunfish is one of, it is the heaviest, and I think, it is the heaviest bony fish. Now, there's another species, not the mola mola, the Mola alexandrini. Oh, that rolled right off the tongue. Which is the giant ocean sunfish. So
awesome.
There's a couple different species, and I'll kind of...
As though the sunfish wasn't big enough.
As though it wasn't big enough. And so I'll kind of talk about both species, both the Mola mola and the Mola alexandrini.
Awesome.
Oh my gosh. So the ocean sunfish, so take what you think of as a fish and turn it into a pancake.
Just chuck it out the window.
Pretty much turn it into a pancake. Make the...
Okay, I see where you're going with that.
Yeah, make the dorsal fin, so the fin that's on the back of the fish, make it actual like solid fish skin and scales, I guess. Make the pelvic fin the same. Have them be completely opposite of each other. The same as the dorsal fin. Have them be exactly opposite of each other. And then that rear fin that most fish have, that ray fin that they use to like flap and swim back and forth, their tail. Yeah, don't have that. You don't have that. You have this round bit instead of what is essentially more sunfish skin. So this
and so just to picture this, they're swimming like on their side, yeah? Or no?
They do swim on their side, but they also will swim vertically.
Okay, so they can do both.
They can do both. Now, generally speaking, this fish...
And I think Rachel, though, when you say a pancake, people are picturing something they could fit in a pan.
Oh, you can't fit this into a pan.
There is not a single listener listening right now. I don't care how big your pan is.
Maybe the world's biggest pancake pan. You buried the lead
here, Rachel. No. I don't. No. You're going to tell us how big they are.
The oceanic sunfish, generally speaking, they have their beak. They have a beak. So they're from their mouth to what is essentially their...
Like a Furby.
Right. It's just like a Furby. To the end of, I guess, their tail, you would call it. It's actually a special... that actually is a special feature that we're going to talk about because
okay,
that is actually shorter than from the tip of the dorsal fin to the tip of the pelvic fin. They tend to be taller,
which is so
it's
weird.
so wild.
Okay.
So an average adults, mature ocean sunfish, which by the way, it takes them about 20 years to be like full grown. So I'm just gonna drop that tidbit there.
Lovely.
The average length, so the mouth to the tail is a Kirk.
Right, tip to tail.
It's about a Kirk.
It's a Kirk. Well, that's not a unit of measure we use on the show a lot. That's about 6 feet.
So it's about an average of about 6 feet. The other direction for the oceanic sunfish is 8 feet. So 1.5 Rachels, pretty much.
Jeez. So like 8 feet tall, 6 feet long, and how do you know how wide they are?
They're really not like wide. That's not a number that actually they're pretty flat. So that's not a number that I really have. So
I got a picture like about a foot or so.
Yeah,
probably.
they're really thin fish.
Based on the photos I've seen.
Which is hilarious because they can range anywhere from 545 pounds to 2,205 pounds.
Oh, that's not gonna your little 50-pound test line down at the pond's not it's gonna
snap immediately.
It's not working.
To convert that for everybody, it's 247 to 1,000 kilograms. But to make things just a little bit better, that's just the oceanic sunfish. That's not the giant sunfish, which looks
I'm excited
very
to see
similar.
How much bigger it is.
But they just have an added like bump on their forehead. So they're sometimes called the bump head sunfish.
That doesn't seem very nice.
It doesn't. So for the giant sunfish, they actually are so the length, so from mouth to tail, that's 11 feet.
The tail, yeah. Oh, wow. Okay.
And from the tip of their dorsal fin to the tip of their pelvic fin, 14 feet.
Oh, man. So, 14 foot tall
feet.
Fish. That's 11 feet long. I knew they were big. I didn't have the numbers in my head because this is not a species that I have ever encountered or talk about usually. But I've just kind of heard about out in the world.
Yeah.
Good gravy. That is large.
That is so large.
I'm sort of flabbergasted. I'm glad I was sitting down. And good news, podcast listeners, I was not wearing socks when we started recording. Otherwise, they would have been blown smooth off across the room.
That's more than 2 Rachels. That is 2 Rachels and a bit. That's pretty much 2 Kirks and a bit.
That's more than 2 Kirks.
That's 2 Kirks and a bit.
That's like, another Kirk standing on my shoulders and then like, raising the hand to ask a question.
Exactly.
That's a weird image, but that's big.
It's a huge fish.
I think we're taking the unit of measure a little farther. Yeah. There's this whole thing of that like Americans will go to any kind of length possible to avoid using the metric system, and here we are using Kirks and Rachels instead of the metric system.
Right.
Like when the Chinese spy balloon was over the U.S., they kept on referring it to the size of 3s. Was it the size of 3 school buses? Yeah. But they didn't really specify like if that was end to end or side by side or
which size school bus.
No, it's a standard size school bus, but it was sort of like school bus is not a unit of measure. Just like say how big it was. Use meters or use feet. It's fine.
Ugh.
But yeah, I still like the Rachel's unit of measure.
It's really fun.
Sorry, we're gonna keep doing it.
And to give that even more context, this is 6,000 pounds.
Oh.
So The
Wow.
other ones,
a
the
big fish.
oceanic sunfish, those are 2,000 pounds. So that's still a lot. But
You're gonna need so much shore lunch to batter that sucker
oh,
up. Like
so much.
And the pan size you're gonna need is
Well,
huge,
which is funny because
as we've mentioned.
yeah, you're gonna need a huge pan. Which is actually really funny because it is actually a delicacy in some countries, which is
Oh, really? Okay.
which is wild.
I was gonna ask, do people eat them?
Yeah, people do eat them. They're not great. Like
Have you had one, Rachel? Do you know they're not
that
great?
is fair. I have not. I'm willing
Full
to
disclosure,
try.
I do not eat fish, so I really can't. I can tell you it tastes awful.
I like fish. Fish don't always like me is the problem. Yeah.
Oh, well,
Fun fact about Rachel.
you
She
go.
has I have very specific fish allergies. Anyway,
Huh.
fun times. Anyway, so these are like just wild fins that are wild fish, not fins. Well, they have wild fins as well, but
They have wild fins. You were
Yeah.
accurate, yeah.
But they're just a wild fish just by the sheer size. We were
Oh, yeah.
talking a little bit about people eating them, but there isn't a lot of like animals that eat them in the first place. Once they get to like their
Okay.
full adult size, like attacks and predation on
'Cause they're
them
so big, yeah.
tend to not occur as much.
Okay.
Part of that is actually thought to be because they're poor nutrition. Primarily, what a lot of the sunfish eats is jellyfish, which doesn't give a lot of
Oh, wow.
nutritional value to them.
Yeah, no kidding.
And it doesn't give them a lot of nutrition either. But they also are generalists. They will eat a lot of jellyfish, but they'll also eat like small fish, squid, crustaceans. But they'll eat whatever they can find. And actually, one thing that used to be well known about, or what people used to think, because they're so big, that they weren't really good swimmers, because their fins, which I'll get to in a minute, are just seem like they're very ineffective. And like you mentioned earlier, like you thought that they swim like flat with
I've seen photos of them like flat, like in the ocean.
yeah, and they do that absolutely. Actually, they've been witnessed doing like a basking behavior at the surface of the ocean, but they have been
Yeah, that's what I've seen. Yeah.
And they'll like present themselves just to like, I guess, and scientists guess to be like thermally recharging, because they will actually
Sure.
dive down into deeper, colder water in order to actually feed and get fish, as well as like
Nice.
squid and sometimes even like eelgrass. But because of that, scientists also thought like they seem to just follow the currents. They don't seem to really like actively like swim or do much.
Well, their food doesn't just sort of floats in the currents. So if you float in the currents and your food floats in the currents, that's a pretty good place to
Exactly. Which is funny because they actually are pretty good swimmers. Or well, they're okay. They're decent swimmers.
Okay.
Scientists were able to tag a sunfish, and they found that in one day it actually was able to. This particular sunfish was able to traverse 16 miles. Not necessarily like completely going like traveling that long of a distance. Some of it was going down into the ocean or down deeper in the ocean and things like that.
Okay.
But still, even with all of that, they are still decently clumsy swimmers. Part of it is because that large dorsal fin and that large pelvic fin that they have. But it's also mostly due to what we would call their tail fin. They don't really have one.
Yeah, tell me about that.
It's called a clavis. And that is what science...
And what is it?
So apparently that fin, when they're born, when they're are hatched from their egg and are little fish fry, they have a bunch of little fins. And instead of growing that back fin, that tail fin, instead of it growing with the fish, it actually folds in on itself and keeps folding in on itself.
Okay.
It never grows.
What?
It just folds in. Creating this rudder system to be able to like, and reason why it's kind of a big circle, which is why I refer to it as a pancake.
Right.
That clavis, it is pretty much just a rudder, and that's pretty much it.
Oh, so it's not used for locomotion.
Not really. It's just a rudder. They can't really use it all that much because it's just a it honestly is just a bunch of fins that have folded in on itself over and over to be leathery texture.
What it looks like to me, I'm looking at a picture here. For those of you at home who can't, look at a picture right now or driving or something, if you know like if you have like a pot pie or something, and there's that like the edge of the pie crust that's been all like undulates up and down where someone's gone through and pinched it with their thumb. That's kind of what the tail looks like. It looks like a crimped pie crust instead of a tail.
Yes,
sticking out the back of the animal.
But
weird.
It's wild.
So weird.
And actually, I've been misspeaking. It's not a pelvic fin because they don't have pelvic fins. It is the anal fin.
Okay.
So they have a dorsal and
because it's really far
fin.
back, so that makes sense.
And then
because if you're picturing that these fins are coming off like the middle of this fish, you're picturing it wrong.
It's all
like
at the end.
Oval. Everything's at the back. There's this little crimped fin at the back, which I guess isn't really even a fin, and then you have the anal fin and the pectoral fin, which look like they're the same size essentially, like wings kind of sticking off at the back of the fish. This is such a strange creature.
It is a wild creature. It's been on my list for a long time, Kirk.
Yeah, and I know you're going to put photos up on
100%. I actually have just one more thing that I really wanted to touch on about the oceanic sunfish. And so we've talked about, we were just talking about how its fins are weird and how it's not like the best at swimming. Like it'll do it, but it's not great at it. Well, they have been seen to escape what predators they do have, and and those include like orcas and like some sharks and things like that. But it doesn't really like seem to super like they don't tend to be like predated upon all that much, just because they're so big and they're just so nutrient lacking.
Poor, yeah.
They have actually been found to be able to move rapidly enough in some cases to breach the water.
Oh, wow. That'd be a sight to see.
Up to 10 feet out of the water.
Wow.
So you have this big,
I want to see that now.
2,000 to 5,000 to 6,000 pound fish.
Just
huge.
Out of the water. Whoosh, 10 feet up.
10 feet up because of how like they are able to do that in a short amount of time. But they, that would be really wild cool. To see. You do get to, they are around, obviously they're a vulnerable species. And they're often found alone, but like a fish this large, like that would be amazing to see.
Very much.
Yeah. So I just wanted to I wanted to tell you all about oceanic sunfish because it's absolutely wild, and we haven't covered it yet.
Awesome. Thanks so
much. Thank you all for listening. We will see you next week. Until next time, bye.
Bye-bye.
Thanks everyone for listening to today's show. Be sure to subscribe. New episodes drop every Wednesday, and we love sharing this strange world with all of our listeners. If you would be so kind as to leave us a 5-star review, that would be great. It lets other lovers of the strange discover the show. You can reach out to us on social media by searching for Strange by Nature Podcast on Twitter, Facebook, and Instagram. You can send us an email as well. Our address is contact@strangebynaturepodcast.com. If you want more information about the show, you can also check out our website, which is strangebynaturepodcast.com. Until next week, get outside, stay curious, and embrace the strange.